everyone. Sean Moriarty. As said, I'm the co-creator of NX, author of a couple of Elixir books, and just generally do a lot of machine learning stuff in Elixir. So this talk is somewhat machine learning related. It's really focused on large language models. Not going to really talk about NX, but you can hopefully see how this is going to tie into NX. This talk is about my new favorite library in the Elixir ecosystem called Instructor. That's inspired by a library in the Python ecosystem that's pretty popular, also called Instructor. And the subtitle is How to Use LLMs Correctly in Production. And that's a pretty strong assertion, but I think as you see this talk, I think it should, hopefully, if you're not familiar with it, change the way you think about using large language models in a production setting. So I'm going to guess that a lot of you are probably using large language models right now in one form or another. I don't know if by a show of hands, how many people are using large language models in their production app, not just using like ChatGPT. I can actually see the audience, so I'm just curious to see what the results are here. Maybe, I don't know. It's actually kind of hard to see on the screen, but I'm going to assume that a lot of people are using large language models in one form or another to augment some workflow. But I would assert that a lot of people are not using large language models correctly. Or if they are trying to use large language models, you might find that it's very difficult to control some of these open-ended generations and to integrate them into what you would call, maybe it's harsh to say a legacy software workflow, but certainly a deterministic software workflow. So I did a talk at MPEX in 2023. It's on YouTube if you want to go watch it, but it's essentially a rant about how the large language model revolution is something strange, because I think as ChatGPT and these other production large language models have come out, everyone has looked at them and said, yeah, these are really awesome, they're really powerful, but I haven't really found a killer use case for large language models outside of people that are building chat apps. And so what I mean by that is that people that are building products that are powered by large language models usually try to market the large language model as the application and not necessarily as a fundamental part of their application. So essentially the theme of the talk is that you shouldn't just build an app that's enabled by a large language model for the sake of it, because large language models are powerful tools that are meant to augment your application, but they're not necessarily meant to be the actual sole workflow in your application. And this kind of goes along the lines of, so when you first saw an LLM, you probably thought of a million ways that could be used in your application. I think I was kind of the same way. I thought, you see what these large language models can do, and you think to yourself, this is incredibly useful. This is something that I could totally use. But then when you actually got around to it, integrating it into your application, you realize that it's very hard to integrate a non-deterministic, open-ended string completer, and that's a harsh word. I know that large language models are not necessarily string completers, but integrating something that does what a large language model does into your old school software application is hard. And the truth is that because the primary purpose of all software applications is to turn data into useful outcomes, and traditionally we model data in some, I would say, language-specific way. So in Elixir, we have Ecto, and so we model our domain using Ecto, or as we're going to see later on with Ash. So there's a lot of ways to model your domain, your problem, but these necessarily don't tie directly with what a large language model does. So it's very rare for your domain to perfectly match what a large language model does and provides to you. That's chat completions and open-ended completions. And so for that reason, it's very difficult to integrate these things directly into your applications. So yeah, once upon a time, and this is my talk in MPEX, I said that we should start thinking of large language models in the same way that we think about databases. And I didn't necessarily mean that in the way that you should go and query a large language model like you would query a database and expect a deterministic output. But it is a useful segue for the concept I'm going to present to you here. So if you think about how you use a database in your application, you have your database on the left, and that maps directly to some schema or ecto schema in your application. So here I have a Postgres database, for example, and I have a contact schema, and that contact schema has a first name, last name, email, and phone number. So this is kind of useful because this is essentially exactly what Instructor gives us, where I can take the outputs of a large language model and map that directly to an ecto schema. In this sense, I can treat the outputs of my large language model as I would say, a first-class citizen of my application. So this is essentially what instructor is. Instructor is it's a way to do what we call structured prompting. So structured prompting is if you're familiar with the OpenAI function calling, that is essentially a way to get structured or JSON outputs from large language models in a reliable way. So if you have worked with large language models pre-function calling, you might have had some interesting workflows where you're, prompting a large language model to please give you JSON outputs, or, please separate each whatever output by a new line so I can then have some weird string parsing and hope that the large language model gives me a correct output, and doesn't have any trailing new lines or trailing characters or anything that sort of mess up this deterministic workflow. The original instructor library is actually a Python library that maps large language model outputs to Pydantic models. So if you're familiar with the Python ecosystem, Pydantic is similar to Ecto. It's just a modeling library where I can represent data structures with, like, I would say, safe typing and all these good things. And it essentially, what instructor does in the Python ecosystem is it maps large language model outputs to Pydantic models. This instructor EX library is written by Thomas Millar. I've got his Twitter linked right there. And it's an exact clone of what instructor is for the Python ecosystem, but written in Elixir. If you're a JavaScript fan, there's also an instructor library for Zod, I think it is the modeling library in JavaScript. So just an interesting tidbit. But instructor is something that you can replicate across a number of different languages because it's a relatively simple concept. So as I stated before, what it does is it coaxes your large language model outputs into Ecto schemas so you can treat them as a native part of your application. So I have my Ecto schema for a contact here, and then I create a validation change set. So here I am taking a contact, or that should be a change set. I validate the fields that I want to be required. I validate my email, and then I call a chat completion here. So this is an example. So, let's say, for example, you have an intake form where someone can just leave some sort of request for help with their contact information. And you can see how this would very easily be replaced with traditional form. But if for whatever reason you're getting an open-ended output like this from something somewhere, and I've got some examples in my demonstration here in a second, and then I can pass this open-ended content to this chat completion, and I have this response model there, which is my contact, and this will actually get the output will get coaxed into that Ecto model, so then I can use that contact directly in my application. So now on to the more interesting part of the talk. We will go into the demonstrations. Can you all see my live book here? Is the font okay? Yes, no? I can make it a little bit bigger. Ooh. Well, I guess I'll continue through.
Okay, can you make it a bit bigger?
A bit bigger? Okay. Is that good?
Is that okay? Okay, we can continue. Thanks.
Okay, cool. Yeah, so this is that Ecto schema that I had there in my example. So you can see I have this contact, and I'm using an embedded schema here because it's not mapping to any sort of like table or external data store, but it very easily could if you really wanted it to. I define a validation change set. And so this is something that you probably already have in your application. You have a ton of schemas that represent your domain or your problem domain. And so I define this module, and then I have my example content here. So I have this saying, hi, my name is Sean Moriarty, and I'm looking for help. My email is this email, and my phone number is this. And so this is just a traditional data extraction task. So I'm taking some open-ended input, and I'm trying to extract a structured output from it. And this is something, if you were using LLMs like pre-function calling and pre-instructor, you probably have some like crazy prompt that is begging your large language model to please return you valid JSON, to please return you like XML or something that you can reliably parse, and you're just hoping that it gives you something correct. With instructor, I can simply take this and it will actually call it. And I know I'm using OpenAI here, but this is something that it's an adapter-based library, so I could very easily replace this with an open source large language model like Llama 3 or whatever else is out there. And you can see that running this is going to use, it's going to call out to GPT 3.5, and then it's actually going to parse the returned value into this context schema. One thing you notice is it actually has an ID. That's because this Ecto schema has an ID by default, so I can just enable or disable this primary key, and then it should not return an ID with my result there. And you can see it actually correctly extracted the data that I wanted from this open-ended output. if you actually get bad data because you're just working with change sets here, so I have this validate change set. If for some reason, and this is probably a pretty bad example, but if you don't want your large language model to like extract bad information for whatever reason, you can just enforce those validations as you would as if it was any other regular part of your application. So here I have the same exact prompt, but I'm saying my email is bad_email, which is obviously not a valid email. And I give this to instructor. And rather than getting some sort of like JSON or something that I then have to validate, I actually get a change set back that I can handle directly in my application. So this is something that's very convenient because if you worked in Elixir, you've obviously worked with Ecto, you've worked with change sets. And so it's something that should be very familiar and it's very easy to integrate directly into your application. Now, there are some other things you can do with instructor that I think are pretty interesting. So I call these like smart validations. So if you've done things like worked with like spam filters, or a good example would be like validating like profanity or whether or not speech is hate speech or something in a machine learning setting. You know how difficult that can be, and it's also something that like usually requires a bunch of glue code to pass your regular data through some like machine learning service. With instructor, it's actually relatively simple to do LLM-based validation. So it provides this convenient validate with LLM that just works natively on the change set. So in this example, I have a tweet here with a username and a string. And my validation is just a prompt here. So I'm telling instructor that I do not want it to allow any tweets to get through this filter that are about crypto bots. If you've been on Twitter, I'm sure you've seen all of the crypto bot tweets that are out there. So I say, hey, look at this content field and make sure that you return an error on this change set if there are tweets here about crypto bots. And so this is just a regular Ecto schema. If I have some software that like extracts tweets for whatever reason, then I can just use this without having to do anything crazy with my application. Now I have this tweet and I do a cast all here, which is going to cast this map here into to that schema. And then I'm going to validate that this is, either a crypto bot tweet or not. So this is like an actual spam tweet that I had pulled directly from Twitter. And I do this cast all, and it's going to actually call out to GPT 3.5, and it returns these errors. And this says, hey, the content is invalid because it contains hashtags related to cryptocurrency, blah, 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 blah. And so this is something that you could actually like return to your users. Hey, like this is spam. This is an incorrect, this is spam, this is profanity, this is hate speech, this is whatever. So you can do these non-deterministic or these very involved validations without having to come up with some like crazy logic or building out like an external or separate machine learning service. And this will actually, I think it should not return an error here. In some cases it does, yeah. So it's not perfect, and this is something. There was a quote I saw like very recently about working with large language models that like I think it was they're very powerful, but like sometimes you build in a non-deterministic part of your application that's impossible to debug, and so there are downsides to using them. And so this is maybe a good example of that, and that it is saying that this is an invalid tweet, and it could be that just because we're using GPT 3.5, but just a good example of some validations that you can do. One of the things I really like about instructor and large language models in particular is that if you have a like machine learning based application that relies on several different machine learning models, you can usually simplify your machine learning deployment by using just say like a single large language model, and then taking advantage of all of these different, I would say like structured outputs to model these problems. So a good simple example here is, say you have an application that parses news articles and extracts like named entities, it extracts the sentiment, it extracts the topic, and does a number of these like NLP-based enrichments on this article. And so this is something that before LLMs you would have to do with multiple different models. You would train a model that is a like named entity recognition model specifically for this problem. You might train a sentiment analysis model specifically for that problem, and you might train a topic model. With instructor and large language models, I can come in and just define a schema for each of these problem domains. So here for named entity recognition, I have an entity, which is a string, and then a class. So an entity is either a person, organization, location, or other. Sentiment analysis is just a classification problem. So I just define a schema with a class that can be positive, negative, or neutral. And then topic modeling. So I can say that this article topic is about energy, finance, politics, sports, or other. And so I can define all of these, and then I would say is the world's simplest machine learning service here. It's just a series of chat completions. So I have NER here, and rather than having a separate NER model, I'm just using, and that should be turbo, I'm just using instructor. And then I have sentiment analysis, and same thing, it's just an instructor call with a different response model. And then I can run all of these, and I've got a long article I pulled here. So I'm a big baseball fan, Philadelphia Phillies. I pulled a Phillies article here if anybody watches the Major League Baseball in the United States. And I can do sentiment analysis, and this will return, hey, positive, and this topic is about sports. And so this is an example of doing all of these things separately. Another cool thing you can do with instructor is you can actually have nested schemas. So if I have a set of enrichments I want to apply to an article, then I can just define a schema that has all of those separate enrichments I want to apply. So in this case, I have my article, and I want to embed many entities. So I want to extract all of the named entities from the article. I have a topic, which is just like the topic that I described above, and then the sentiment. And then I'm going to include additional field here, and I'm going to say I also want a summary of the article as well. And so I'm going to define this schema, and then I run this chat completion. I'm just going to say enrich the following article and let this run. And this could take a little bit because it is a little bit more of an involved task. I'll wait for this to complete. And I get these outputs here. And so you can see it actually extracted all of the entities, and you got to remember to do that primary key false. I did not do that there, but it will fill that in. But it gives me all of these entities that it pulled out from that article here. It tells me the topic is sports, it tells me the sentiment, and it actually gives me a nice summary. And so this is I think it's really cool because I didn't actually do much prompt engineering work here. I didn't have to do much of anything to tell GPT 3.5 that this is what I wanted. I just defined my schemas, and it gave me what I wanted back. So you can actually, and there's an example of this, you can describe each of the fields you want. So if your problem is a bit more involved, you can actually provide a documentation for your schema and describe each of the fields. So this is an example of using instructor in sort of like an agentic workflow. If you're building something that relies on agents or decision making, then I think instructors is a pretty good example or pretty good library for doing that. So this is actually a schema that I used for a home automation project that I did. So I have a smart home it's got smart locks and cameras and alarms and everything. And so I defined a schema for an agent that would decide based on a command that I gave it whether or not to say lock or unlock a door, to set the alarm to a certain status, to view one of the cameras, or to just do nothing depending on what I said. And so here I'm actually describing the action I want it to take. So for a problem where it's not necessarily, I would say, described well with what your schema is, you can expand upon what each of the fields is. So in this case, I have my actions, and I describe what the actions are and the behavior that I want based on the prompt that I'm going to give it. I have my states and my camera. And so I have the schema, I'm going to define it. And then I have this chat completion with a system prompt that says, turn the user command into a home action. So in this case, I'm saying, hey, can you lock my front door? And I run this, and my result is set lock to the lock state of lock. And I can say, turn on my alarm. And then I get a set alarm and alarm state home. So this is something where you can see how I can very easily turn this into something that is, uses an API or makes a call out to some home security API or whatever. So I would say with very minimal prompting, I get a data structure back that is native to my application and makes things really, really easy to work with. Final note that is pretty awesome is instructor also supports vision models. So we have these large language vision models like GPT-4 Vision. If you have access to GPT-4 Vision or Lava, for example, if you're using the Llama CPP, then I can do the same exact thing I would do as if I was working with text, and I just define a schema. So in this case, I have a receipt, and then let's say I want to take a picture of a receipt, and I want to get the expenses on that receipt, and as well as the total from the receipt. Now I'll pull up a picture of what the receipt looks like here in a second. So I can define this schema, and then I have this PNG that I'm going to read here, and I turn that into a base64 image, and I'm going to use GPT-4 to actually extract the expenses on this receipt. And so this will take a second. And now you see that it has actually pulled out the expenses. It has front and rear brake cables, quantity of one, the prices, and then the total as well. And so if I pull up a picture of this, hopefully I can share this picture. Let me see. I should have prepared for this. Let me paste it into this slideshow. So this is the actual receipt, and I will full screen this. And so you can see 154.06 was the actual price I got. That's the total. And front and rear brake cables, new set of pedal arms. And so this actually matches the output that I got from instructor there. So hopefully that very brief introduction to instructor gives you sort of like an idea of the powerful things you can do with structured prompting. I think if you're working with large language models in like a production setting, that you should be using something like instructor, unless you're building, let's say, like a chat application or something that involves like open-ended chat. Then I think it's okay to just work with the large language models as they are. But for many of us, chat's not the domain that we're working in, and so it requires this sort of glue that allows us to marry the power of large language models with our traditional software application. Now, I know I did work with OpenAI in this, which might be a faux pas for me as the one of the maintainers of NX and Axon and Bumblebee. This will come to Bumblebee at some point. I have to finish something that's called constrained sampling. So what constrained sampling is basically defining a grammar for your large language model's generation to follow. And then your model will always generate valid versions of that grammar. So you can pass grammars for JSON in this case, or you can pass grammars for actual languages. In some cases, using constrained sampling can actually be much faster and more memory efficient. There's actually some work from a library called VLLM that I think it's VLM, it might be someone else, but that shows that constrained sampling can be faster. And this is something that hopefully we get built into Bumblebee. Some of the other things working with large language models, quantization and model partitioning. So if you want to be able to run like Llama 70B on a consumer hardware or Llama 400B on consumer hardware, then these are some things that are required and hopefully are coming soon to NX and Bumblebee.